In this video, you are going to learn not only how to code a cool custom cinematic in your very own video game, but you're really going to be learning a fundamental coding pattern that you can extend and you can scale for massive video games. I'll be using the opening cinematic from Mega Man X3 that I coded in a previous video. Please follow this pattern. You can use the video as a reference. I'll be posting a link to the code repo in GitHub in the description below, so if you get lost, you can follow along. But without further ado, let's jump right into it. Where you put your cinematic in your code depends on what the cinematic is for. The example I'll be using is an opening scene cinematic. So my cinematic will be created after the game is initialized, during the process of loading the level. Depending on the paradigm you are coding your video game in, you can either make it a function or an instantiated object of a class. I used OOP, so mine is a class. This class has three methods: enter, execute, and an exit method. If we go back to the game loop in index.js, we see that this line at 240 pushes the event into a queue that will call its enter function on the first round of the game loop. This made sense due to the way I structured this game, but yours does not need to be so complicated. You can try just calling the enter function. Once this is done, let's take a look at how I structured the intro cinematic class. A cinematic can be created by class methods or just a standalone function, but the idea is the same. A cinematic is just a series of events that occur one after the other. These events are controlled, and usually the other things going around in the game are temporarily paused. In order to pause those things, you may need to pass references to the external variables in your code. So for example, I wanted to control the gravity a bit more granularly, so I passed a variable that's a reference to my physics engine of my game in order to perform operations with the physics engine inside of the intro cinematic. Below, you'll see some arrays that will hold the objects created for the scene. We'll use these arrays in order to manipulate the objects, as well as to get rid of them when the cinematic is complete. Finally, we will store values inside of the this.moments object. Each value will act as a flag in order to indicate when an action in the cinematic has been completed in order to signal to the game that the next action should fire. As you can see, each action corresponds to some scene happening inside the cinematic. Now we'll get into the weeds with this and discuss the enter, execute, and exit functions. Now theoretically, again, you can have all these just bunched up in one giant function, but I like to separate concerns to keep things organized. The enter function will be used to create options at the start of the cinematic, while the exit function will be used to clean up all of those objects that are created. The execute function will contain the logic that manipulates these objects which are created and achieves the desired result that you're looking to make. If we expand this enter function, what is happening here is I'm creating all of the background tiles for not just the level itself, since it is an intro cinematic, but also the sprites like the clouds, which will not be present later after the cinematic is finished. At the very end of all of this, the execute function will be called on the next pass of the game loop. In the execute function, the logic required for your specific scene is obviously going to change very much from my scene. However, what you should take away from this video is the process of using these action flags combined with conditional statements in order to make the actions occur in order. I want to put a very heavy emphasis on that. After the cinematic is completed, you will then clean up the objects created in your cinematic and call the exit function if you're following my pattern. Finally, we'll clean up the objects that were created. My architecture handles this by pushing the object references into a queue that will then be looped through and have each object deleted on the next pass of the game loop. Most high-level languages have garbage collection features now, and the language I'm using, JavaScript, also does have this feature. However, if you're using something more low-level, like C or C++, you'll need to clean up after yourself. As a programmer, it's always a good practice to delete objects you're no longer using in order to prevent bugs or data leaks in the future. If you enjoyed this video, please consider subscribing to me to help me grow the channel. Thank you.